Good day, students. Welcome to math.serve.com, where we don't just solve, we teach. In this clip, we're going to be going over problems 6 to 10 of the Algebra 2 Trig New York Regents exam for June 2016. If you have any questions during the course of this presentation, feel free to ask your questions in the comment section below, and we'll be glad to support you. Alright, let's take a look at question number 6. It reads, what is the domain of the relation? So we have the graph of a relation here, clearly not a function. So what is the domain? Now, one thing you have to recall is that when you're given the graph of a relation, the domain basically is the projection of the graph on the x-axis, okay, or the horizontal span of the graph. So in this graph we have right here, the domain is along the x-axis. If we project this graph on the x-axis, how wide is it going to be? Okay, domain is x, range is the y. So if we project the graph on the y-axis, how high is it going to go and how low is going to go, and now what intervals does it cover in the interior of the highest and lowest points, if they exist. Okay, so since we're doing domain, we're going to project the graph on the x-axis. Now, what do I mean by projecting the graph on the x-axis? Now, think about the graph as lines, and then you can take something like a flashlight. Okay, so let's say you have a flashlight up here, and then you flash the flashlight on the graph. What kind of shadow does the portion above the x-axis project on the x-axis? And then you take another flashlight to the bottom, and then you flash it on the curve. What shadow does the portion below the x-axis project on the x-axis? You combine that with the portion that's already on the x-axis, and that will be your domain. Okay, so let's say we have this portion right here, this portion, let me highlight it in blue, this portion right here, and this portion above the x-axis. If I flash a flashlight above these two lines, these two segments, what kind of shadow will be projected here? We're going to have a closed circle here, and then it's going to go on. Now this is an open circle, but this is a closed circle, so this closed circle gets projected right here. So it's continuous, and then that open circle gets projected right there. Okay, so you have this entire line right there. Let me change the color so you can see. So let's make it a blue line. Alright, so it's going to be something like this. Oh, that color didn't work. Blue. Okay, so it's going to be something like this. Okay, and then this portion is already on the x-axis, which is good. So we have that close interval. And if you take a look at the last piece right here, it is beneath the x-axis. So if we take our flashlight and flash it on this portion, this segment right here, what kind of shadow will be projected on the x-axis? You have a closed circle here, you have a closed circle there, closed circle, and everything in between. Okay, so what you have is a number line situation that goes from -2 all the way down to 2 with 2 excluded. Okay, as a result of the downward and upward projection of the graph, including the portion of the graph that's already on the x-axis. So this line right here, this inequality represents the domain. Okay, so it's going to be a set of x's such that you're going from -2 is included, so you put this line here, less than or equal to x, and then is less than 2 is excluded because the endpoint is an open circle, hence an open circle will be projected on the x-axis. So you go from -2 to 2 with -2 included. Answer for number 6 is option number 3. Alright, let's take a look at number 7. Number 7 reads, the mathematics club will select a president, a vice president, and a treasurer for the club. If there are 15 members in the club, how many different selections of a president, a vice president, and a treasurer are possible if each club member can be selected to only one position? Okay, so this problem is a selection problem. The question is it combination or permutation? This is a question that most students normally ask permutation when they're dealing with counting or selection problems, okay? So a quick tip to keep in mind is that when you think about permutation, you're thinking about placement, positions, arrangement, or ordering, okay? Combination on the other side has nothing to do with order. It's an unordered selection, okay? So let's take a look at this problem for a second. The question is, are we going to be selecting out of 15 people, are we going to be selecting 3 people with no order, which would be combination, or are we selecting 3 people with a certain order, placement, position, or arrangement? So which one is the correct option here? So if you look at the problem normally tells you which one to select. Okay, we are selecting um, 3 different people for president, vice president, and treasurer. What can we call these titles? These are positions. Okay, so when you're selecting and placing your selections in a position, there is a certain order going on there. Okay, so you can see the president is the first, vice president is the second, treasurer is the third. Okay, so is this combination or permutation? Well, since it is a ordered selection, basically selecting people to fill positions, this is permutation and not combination. Okay, so 15, arranging out of 15, you're going to be selecting 3 to fill positions. So it's going to be 15 P3. That will be the answer. Okay, so all we simply do is plug this into our calculator to get our final result. Alright, so let's go ahead and compute that. We have 15, and then we're going to be placing 3 out of the 15. So I'm going to go to my catalog because that's the quickest way to find most things, and I'm going to look for N. So NCR is combination. That's not what we want. We need NPR. Alright, NPR 3. Enter. Your answer is 2,730. So the 2,730 different arrangements to fill these 3 positions out of 15 students. Answer is option number 3. Alright, let's take a look at question 8. It says, for which equation will f of negative 2 equals negative 6? So you can do this with your calculator real quickly by storing negative 2 into x and then evaluating these expressions. But you could do it faster by hand. Okay, but one thing you want to recall or keep in mind, so let's note that if you raise a negative number to an odd power, your answer is going to be negative. If you raise a negative number to an even power, your result is always going to be positive. Okay, so let's keep that in mind. Alright, so I'm going to just test out these options right here. I'm going to plug in negative 2 into them and see if I get negative 6 as my output. Alright, so let's try f of negative 2 for option 1. We're going to have, let me write down what the function is first so no one gets confused. For option 1, we have f of x equals x to the third plus x. Okay, so what is f of negative 2 going to be? You're going to plug in negative 2 raised to the third power plus negative 2. Okay, if you work this out, negative 2 to the third power is negative 8. Plus times minus is minus. Minus 8 minus 2 is negative 10. So that's wrong because we're looking for negative 6. Option 2, we have the function f of x equals x to the fourth minus 5x. If you work that out, you get, so we're going to look for f of negative 2. So that's going to be negative 2 raised to the fourth power minus 5 times negative 2. Just plug in negative 2 for the x's here. Okay, so negative 2 to the fourth power is 2 times 2 times 2 times 2, which is 16. Since it's even power, the minus drops off, so we have 16. Minus times minus is plus, plus 10. 16 plus 10 is 26. That's not what we want. We are looking for negative 6, okay? Alright, so now let's take a look at option 3. For option 3, we have the function f of x equals 4x to the third plus 6x squared minus x. So you're going to plug in negative 2. So that's going to give us 4 times negative 2 to the third plus 6 times negative 2 squared minus negative 2. Okay? Now we're going to use order of operations here. Negative 2 to the third is 8. So we have 4 times actually negative 8. And then negative 2 squared is positive 4. So we have plus 6 times 4, positive. And then minus times minus plus 2. Okay? Alright, let's finish this off. We have 4 times negative 8 is negative 32 plus 24 plus 2. Okay? And then we have negative 32 plus 24 is going to give us negative 8 plus 2, which equals negative 6. And that's the answer that we want. The correct answer is option number 3. Okay, so if you're pretty good with your arithmetic and quick mental computation, it'll be much faster for you to do it by hand. Okay, now let me go ahead and show you how to do this with your calculator. If you don't want to do this, or you want to just let's say you were going through the problems and you had some complications, you couldn't get the correct answer. So what you do is you take 2, clear what we had before, and I'm going to store it in x. Okay, actually not 2, I'm storing negative 2 in x. Enter. And then all you do is you just type in these functions. So you have x raised to the third power plus x. Enter. You get negative 10, which is not what we want. And then we'll do the next one, x raised to the fourth power minus 5x. Enter. 26, that's not what we want. And then the third one is 4x raised to the third power plus 6x to the second minus x. Bam, negative 6. So we can clearly see that our answer is option number 3. Alright, let's take a look at question 9. It says, what is the product of x squared minus 2x plus 3 and x plus 1? Alright, I'm going to show you a neat little shortcut you could use to quickly find the answer, and then I'll solve the whole problem for you, okay? Now, whenever you're multiplying polynomial expressions, you can predict what the constant term of the result is going to be. How can you do that? Well, all you simply do is you look at the constants of the polynomial factors you're multiplying, multiply them together, and that will basically tell you what the constant of the product will be. Alright, so when you're distributing this all the way, you end up by multiplying 3 by 1. What is 3 times 1? 3 times 1 is 3. So the option that has 3 as a constant, that's your correct answer. So we can see that the answer is option number 1 without even doing any without doing any work. Okay, so let me go ahead and do the work for you so you can see that what I'm saying is true. Okay, so we have x squared minus 2x plus 3. I'm going to multiply this using something called the box method. Some students like using this method to multiply polynomials. So let me show it to you. It's a nice little way of multiplying polynomials without making too much mistakes. Okay, so we are going to multiply it in this fashion. Okay, so this is x squared, this is negative 2x, and this is 3. Let me rewrite it so you can clearly see what we're doing here. So we're going to have this one, you separated, this is x squared column, this is negative 2x, and this is positive 3. We're multiplying by x plus 1, so you put an x here and a 1 here, and then you just multiply. X times x squared is x to the third. Remember, when you're multiplying, you add the exponents, okay? So there's a 1 here, you just add it with the 2. X times negative 2x is negative 2x squared. X times 3 is 3x. Alright? 1 times x squared is x squared. 1 times negative 2x is negative 2x. 1 times 3 is 3. Okay, now if you take a look at what we have here, can you see what the constant is? 1 times 3, 3, which is what we said over here. See that the answer is option 1. But let's finish this off, okay? So we have x to the third, and then check this out. These two terms are like terms, so we can combine them. You're combining the coefficients. Negative 2 plus 1 is negative 1, so negative x squared. And then the 3x and negative 2x are like terms too, same degree. 3 minus 2x is positive 1x, just write it as positive x, plus 3. As you can clearly see, our answer is option number 1. Alright, let's take a look at question number 10. It reads, a principal is concerned about the decline in the number of students who purchase food from the cafeteria. A survey was developed to assist the principal. The most appropriate method would be for the principal to randomly select 100 students from. Now, which of these should the principal select 100 students from? The junior class, student directory, Algebra 2 Trig classes, or the students who are eating during fourth period lunch in the cafeteria? Okay, so let's take a look at this problem for a second. The principal is he wants to conduct a survey. What is a survey about? This survey is a qualitative survey. Okay, is assessing the quality of what? The quality of the food, right? So it's a qualitative survey about the quality of the food in the cafeteria. Now, to determine what's appropriate, we have to make sure that we are selecting people who have done what? People who have eaten the food. Okay? For example, let's say you've never been to the island of Maldives, right? And someone gives you a survey to fill concerning how life is in the Maldives. Can you fill out a survey of a place you've never been to? That makes no sense. Okay, so an appropriate sample space to select from will have to be students who have eaten the food, students who have experience with the food, so they can be able to give the principal a qualitative measure of their satisfaction levels of the food in the cafeteria. Okay, so if you take a look at these four, which one would guarantee the selection of students that have actually eaten food in the cafeteria? Junior class, is there a guarantee that everybody in the junior class has eaten food in the cafeteria? There's no guarantee. You can actually select 100 junior class students and none of them or very few of them have eaten from the cafeteria, so the survey is worthless. Student directory, the same problem. Algebra 2 has nothing to do with the quality of the food. Students who were eating during the fourth period lunch in the cafeteria. Now these students, you see the keyword here, are eating food in the cafeteria. So they are the appropriate students that you can randomly select 100 students from in order for you to basically generate a good qualitative survey concerning the quality of the food in the cafeteria so that the principal can make the necessary changes or improvements to get more people buying food. Alright, so the answer to number 10 is option number 4. Thank you so much for taking the time to watch this presentation. We really appreciate it. If you found the contents of this tutorial helpful to you in your preparation for the Algebra 2 Trig Regents exam or your review of your answers, please give us a thumbs up. Your positive feedback is very valuable to us. Don't forget to subscribe for the remainder of this review series. Any questions or comments, just place it in the comment section below and we'll be glad to support you. More clips can be found on math.serve.com. Thanks again for watching and have a